Hello everyone, welcome back to Bytes of CSE. So in this lecture, we'll be learning about merge sort. So merge sort has three main operations. The first is the divide step, where we keep dividing the arrays into sub-arrays until each sub-array contains just one element. The next step is the conquer step, where we recursively um, sort two arrays, and finally we have the merge step, which merge the sorted array back in linear time. So this is how the algorithm of merge sort looks like. So it takes in three arguments. First is the ARR, which stands for the array that is to be sorted. Low is the lowest index of the array and high is the highest index of the array. And then there is a condition checking. Why, I'll come to it later. And these three steps actually do the division part of the array. And this is another algorithm which does the conquer and the merge part. So as you can see, there's a condition checking if low is less than high. This is just to ensure that the array contains more than one element, because if the array already contains one element, the sub array to be specific, then there is no further need to divide the array. So to stop that, we have kept this condition checking if low is less than high. So this finds the midpoint of the array, and then it calls a merge sort on the left part of the array till mid, that is from low to mid, and another merge sort on the right part of the array, that is from mid plus 1 to high, which is the highest index of the array. And finally, when the division part is done, this is a recursive algorithm, as you can see, then this merging will take place, and merge accepts four arguments: the array, the low, that is the lowest index, the mid index, and the high index. Now let us see that how this recursion takes place. So let's take an example. This is an unsorted array, and since I have used the indexing from 0, it looks like this. So there are 7 elements in this array, so the indexing starts from 0 and ends at 6. This is the highest index. So the low value is 0 and the high value is 6. So in this case, I am going to represent merge sort as MS. And for this breakdown, just for simplicity of representation, I'm going to avoid this argument ARR. I'm only going to work with the indices. So I'm going to consider only the indices low and high for this. And for this merge, I'm going to represent that as M. And again, I'm going to forget about this array for the sake of breaking this down, and I'm going to be considering only the low, mid, and high indices. So the first merge sort will be called on these two, on the array values 0 to 6, the array indices values rather. So MS 0, 6. Now this checking, of course, is true, and now we have to find the midpoint, which is in this case is 3. And now here the floor function, what it does, it makes sure that whatever be the value of this, only the integer is returned, and the decimal, anything if there be after the decimal point, is ignored. So MS06 will have the midpoint of 3, and a merge sort will be called on 0 to mid, that is from 0 to 3, to mid plus 1, that is from 4 to 6. Come to this point, this is going to be the midpoint, that is 1, and a merge sort is called on 0 to 1 and from 2 to 3. Considering this part, 0 is going to be the midpoint, and we have MS00 and MS11. So just see, in this case, low is equals to high. Yes, low is equals to high, since we have just one element in this array, so this stops at this point. Coming to this point, this has the mid index as 2, and we have MS22 and MS33. For this part, the midpoint is 5, and we have MS45 and MS66. So this is done, and we move on to this point where this is the midpoint, that is 4, and we have MS44 returning just one element, and MS55. So one thing that is to be noted here is the array indexing is universal. So the sub arrays do not have their own indexing from 0 or 1 or whatever. They are using the original indices that is used in the actual array. So now when we come to this part, so this has only one element and this is returned, and this is returned to the calling function ms01. So ms01 will call this function merge, which has index low, mid and high. So low in this case is 0, mid in this case is 0, and high in this case is 1. So this is going to be M001. Coming to this point, the low value in this case is 2, the mid value is 2, and the high value is 3. So this is going to be M223. Now coming to this part, so they are going to be returned to this function. So the low value is 0, mid is 1, and high is 3. So this is going to be M013. Coming to this part again, so this is going to be the high, this is the mid, this is the low. So this is going to be M445. Now they return to this function M46. So this is the low, this is the mid, this is the high. So we have M456, and finally they return to this original calling function ms06, and ms06 will call now the merge operation on 0, 3 and 6. Now let's see what the merge operation does here. So this is what the merge operation does. I'm going to get into this shortly, but before that, this is what we have done so far, and there are actually 6 merge operations. So now M001 has to work with 2 arrays, each containing 1 element. This has 23 and this has 56. Now let us consider that for this, when arrays are subarrays just contain 1 element each, I'm not getting into this merge function. Instead, I'm just saying what it is actually doing is it will check. Suppose I'm trying to sort the elements in ascending order, that is from lowest value to the highest value. It is going to check that if the element sitting at the lower index, that is 0, is less than this element sitting at the higher index, that is 1. So we are going to actually see that if 23 is less than 56. So in this case it is true. So no change is to be done. They just sit in their own positions, and M001 returns this sub array 23 and 56. So this has the index 0 and this has the index 1. Now coming to this point, M223, so 22 returns this value 45, and 33 returns the value 12. Now we have to do that checking, is if 45 is less than 12. In this case it is not, so we are going to swap the values, and now M223 returns 12 and 45 with the value of 12 sitting at position number 2, and 45 will be placed at index number 3. Now let's move on to this part, M013. So M013 is to actually sort these 2 sorted arrays. This is, you might call, the left part of the array, which is actually present the arrays which contains the indices, the lower value indices, and this you can call the right part of the array, since the indices are higher than these. So these are to be sorted and merged together. So let's come to this particular algorithm. So you have a temporary variable n1 that calculates mid minus low plus 1. So your mid is 1, low is 0 and high is 3. So mid minus low plus 1 is going to give you 2, and your n2 high minus mid is also going to give you 2. So what n1 and n2 does it, this finds the number of elements in the left part of the array returned, and this is going to be getting the number of elements that are present that are returned by the right part of the array. So this you can consider the left part, and this is going to be the right part. So these contain 2 elements each. So now there will be actually a temporary array L and R. So L stands for left and R stands for right here. So L will contain all the elements in order that are returned by M001. So L0 will contain the value 23 and L1 is going to contain the value 56. So this is actually done by these 2 lines of code. See, for I equals to 0 to N1, Li equals to array low plus 1. So this is going to be running from 0 to less than 2, and this is going to be the result. Similarly, we have another for loop for this R part of the array, which is from j equals to 0 to n2, that is from 0 and less than 2. We have R0 to be 12 and we have R1 to be 45. This is 45. Now we come to this part where Ln1 equals to Rn2 equals to n, which is a very large number. So let's do that. I'll show you why it is done. So L2 will have a value n, which is a very large number, and again R2 will also be assigned that same number n. R2 has this same number n. So we have L0 as 23, L1 as 56 and L2 as n, and you have R0 as 12, R1 as 45 and R2 as n. So now you reinitialize the values of I and j to 0. Now we take another variable k, we start a for loop from k equals to low to high. So what we do here is we do the first checking. If Li is less than Rj, so the value starts from 0. So k equals to low, which is low in this case is 0. So the value of k for the first iteration is 0. Now your I is referring to this and j is referring to this L0 element. So first checking is if 23, that is this element, is less than R0, that is 12. So this condition is false. So we move on to this else part. So ARRK, that is, let's instead of ARR I'm just considering A. So your AK, that is A0 for this iteration, A0 is going to have this value RJ. RJ means R0, that is going to be 12. And we are going to shift J one step to the right. That is now, since 12 is already taken, J now points to the value 1. That is, actually J is pointing at R1. And I remains at L0. So for the next iteration, now the value of k is 1. Now again we do a checking. So now this time L0 is compared to R1. L0 is 23, R1 is 45. So in this case, this condition is true. Now ARRK, that is A1, is going to have the value Li, that is equal to 23, and now I will be shifted one position to the right. So since this value is already used up, I now comes to this point. The value of I now is 1. Now again this loop is over, this iteration is over. we move on to the next value of k. So k now gets a value of 2. Now when k gets a value of 2, what we do is, now we do a checking. So li is actually l1 and rj is r1. So your l1 contains the value 56 and rj, that is r1, contains the value 45. So now li less than 56 less than 45 is not true. So we move on to this part where ak, that is a2, gets the value of rj. So rj value is, in this case, is 45. And now j is to be moved one position to the right. So technically all the values that this array, this m223 returned, are used up. So now, but j will now point to this value r2, which contains a very large number, that is n. So if we hadn't put this buffer number, this would have shown some sort of an error, right? So now practically j contains the value 2 and I contains the value 1. It's still here. So for the next iteration, the value of k is 3. And now we will compare if 56 is less than n. Now n is a very large number, so naturally this condition is going to be true. And ARRK, or as I'm doing A3, is going to have the value 56. Now by this time, this for loop condition also fails. Again, now this, of course, I is going to be moving to one part right, and now I is going to be pointing at this L2. So now at this position, this for loop condition is also satisfied. So this loop ends, and this is what you get as a result. So M013 returns 12, 23, 45 and 56. Similarly for this case, 52 and 98 is returned. M456 returns 52, 81 and 98. And finally, when these two are compared, M013 and M456, in this case, this returns the value, the sorted value, the sorted array in ascending order. So I will ask you to just take a screenshot of this and try to find out that if you have any doubt regarding this, please let me know about it. So now let's move on to the complexity of the merge sort. So here this is how the array has been divided. So at each level of recursion, the array is split into two halves until these leaf nodes contain n sub-arrays of size 1. So this is accomplished by O log n time. And we have another part of this merge sort algorithm where at each level of recursion, we merge a total of n elements. Like when we merge all the sub-arrays, we actually merge total of n elements in each level of recursion. So that is accomplished by O(n) time. So the total time needed to sort the array is going to be O(n) into O log n, which is equivalent to O(n) log n. So this is going to be the best case, worst case, and of course the average case complexity, runtime complexity of merge sort algorithm. So that is all for today. Thank you.